Yes, I know you love the chain rules so much that you want more of the chain rules, so we're going to do more. In fact, by the end of this fall, you'll be able to differentiate absolutely anything under the sun. I can throw any expression at you and you can differentiate it. Let's try, for example, let's get started with a horrible looking thing. And this is the kind of thing you're going to see in lots of tests. You have a quotient raised to the fourth power. Right? 2x minus 3 to the fourth power. There you go. Now, if you had a calculator and you were calculating this the old-fashioned way, the last thing you would do is raise something to an exponent. You'd calculate what this is and then raise it to. In other words, this is a power. It's a glob raised to a power. So I'm going to globify this. This is a glob. And then we're going to find the derivative of this. So d over dx. Let's calculate the derivative. Now we know what it is. It's a glob to the fourth. So according to the chain rule that we learned in the last video, and you better go back there if you haven't watched it, because then you won't know what I'm talking about, is 4 globs, 4 times the glob. Remember, this was another name for this was the glob rule. So here's the glob, 3x plus 1, 2x minus 3, raised to the 4 minus 1, which is 3. I don't know where to put these glob outlines sometimes. There it is, 4 times the glob to the third power, times the
derivative
of the glob. Okay, wait a minute, the derivative of the glob. But the glob is a quotient. Oh no. Oh my god, I have to use the quotient rule. Don't panic. If you don't want to use the quotient rule yet, you can do this. You can just write derivative of the glob, and then put your pen down, go get a cup of coffee, have a coffee break. Very good coffee. Come back next year, if you like, and continue the problem where you left off, because this is telling you, this is giving you instructions as to what you should do next. This says, I still have to take the derivative of that quotient. But having had a coffee break, you feel a lot better now, and it's no big deal. So let's copy everything over again, because this is the answer, except the answer was not fully calculated. Now we're going to calculate that using the quotient rule. And we remember the quotient rule from, a couple of videos ago, right? So it's the bottom squared, and then you take the derivative of the top, which is 3, times the bottom left alone, minus top left alone, times the derivative of the bottom. And that is the answer. Now, you must admit that's ugly, so let's try to simplify things a little bit while we're here. Simplifying means multiply this out and cancel some terms. It's an ugly 3, isn't it? If you multiply this out, you get 6x minus 9 minus 6x minus 2. The 6x is canceled, and you're left with minus 11. Times 4 is minus 44. That's all that's left on top. Except for this, which is 3x plus 1 cubed. Notice the bottom has 2x minus 3 once, and then twice again, so it is cubed. It is, 3 times and then twice more, which is to the 5th power. So the numerator is to the 3rd power. And the denominator is to the 3rd power plus another 2, which gives you the 5th power. So I could write it like this. And that's it. Or you could have left it exactly the way it is here. It says negative 44 times this thing times 1 over that. A variety of ways of doing it. But this is the answer. Not too bad. And you are sure to get one of these in your test. Even though I'm not your teacher, I just know your teacher's going to give you things like this. So be prepared for this exam. Maybe not these numbers, something almost the same. Okay, let's try one more. Before we do a more complicated one, we're going to look at a simple one, and then we'll kind of elaborate that a little bit. And the simple one is e to the negative x. Now we know that the derivative of e to the x is e to the x. Ho-hum. Yawn. We know that. But the derivative of e to the negative x, what's that? Well, we have the chain rule to help us. This is e to a little glob, globette. The derivative of e to a little glob is e to the little glob times the derivative of the little glob. This little glob has derivative -1. So it's this times -1, so let's put a minus in front of it. So the derivative of e to the negative x is just minus e to the negative x. Useful information to commit to your memory, so be sure to burn that into your permanent memory. So if anybody in the street stops you and says, "Excuse me, what's the derivative of e to the negative x?" You'll say, negative e to the negative x. Thank you very much. And you'll be able to go on with your street walking or whatever you do. So let's continue by a complicated example. With a complicated example. Lots of e to the x's, e to the negative x's, all mixed together. Not very nice. If you had a calculator and you were calculating that, the last thing you would do is divide the top by the bottom. Because you're dividing, that's the quotient, you have to use the quotient rule. This is a quotient. Quotient. You have no way of avoiding the quotient rule, so you have to use the quotient rule, which says, if you think, scratch your head a little bit, the derivative of the top times the bottom left alone. The derivative of the top, well, that's just e to the x. Let me do that in green, so we know we're taking the derivative. Now, the derivative of e to the minus x, oh, we just burnt that into our memories. That's negative e to the minus x. But there's a minus here, so this becomes a plus. So that is the derivative of the top. Multiplied by the bottom left alone, which looks exactly like the same thing, doesn't it? Minus top left alone, multiplied by the derivative of the bottom, and guess what's going to happen now? E to the x minus e to the negative x. It'll look exactly like that. Divided by the bottom squared. Now if you hand that in, you will lose points for not simplifying. Because this is begging. Can't you see it's just yelling, saying, please simplify me. Simplify this, multiply it out, FOIL it out, whatever you want to call it. E to the x times e to the x is e to the 2x. And then the cross terms. But wait a minute, when I multiply e to the x by e to the negative x, which is its reciprocal, I get 1. So this time this is 1, and there's another 1 giving you 2. And then finally, when you do the last terms, e to the negative x times e to the negative x will be e to the negative x squared, or e to the minus 2x. And that's it. Foil that one. Remember, don't forget to use parentheses, because if you do, you'll have some signs wrong. Almost the same thing, except you get e to the 2x minus 2 plus e to the negative 2x. The difference is in the middle term. Plus 2 here, minus 2 there. And the bottom goes along for the ride. That is already simplifying. Don't multiply that out. Simplifying means make it smaller, not bigger. Okay, stuff cancels here, doesn't it? Let's see what cancels. Now the 2's don't cancel because you got a plus 2 and another plus 2. But this cancels with that, because that's minus. This negative term cancels with this term. It should cancel. Let's see. But I made an error here. You better zoom the camera in and out. There's a slight error here in my sign. What did I do wrong? Let me correct it. That should be a plus. You see what happens when your instructor makes an error? All hell breaks loose. But there it is. That should be a plus, because this time this gives you a plus. Why did I put a minus? I don't know what I was thinking. Okay. Good. That's a plus. That's a minus. They cancel out too. So what's left? 2 plus 2. In other words, 4. That is all that's left in the numerator. And the denominator is the same thing as it was. So that whole thing, this complicated thing, boils down to something very simple. So what's the moral of this? When you multiply things out, watch your signs. I have to follow my own advice occasionally. All right, so I think once you've done this, you can pretty much do just about everything. So have fun and enjoy differentiating.